Okay, right. All right, I think we can start. A few points that we are going to look at. Two things. Okay, wait. Let's wait for Timothy. Whether I'm not sure whether Timothy is coming. He should be. Oh. Okay. Let me check. Oh yeah, I can speak. All right, let me give you a brief uh, plan for today, because as I mentioned, okay, but today has even less, but I still have to do the test because otherwise it's going to be very late. So let me talk about what is going to happen today. First step. Today is, what date is today? Fifth, right? So for today's first, we'll have a test, but before the test, I'm going to give you a quick recap to help you to recall your covalent substances. Test is going to be about 40 minutes, 30 to 40 minutes. So yeah, 40 minutes, okay? Before that, for about half an hour, I'll be going through a revision worksheet for you. So that revision worksheet will be your covalent substances. The covalent substances worksheet, let me see. Okay. So let's go through this quickly. That I will be a good recall for you. For you, I think the office will email you that particular worksheet. I need you to look at this chapter 2 MCQ. The questions are from question 25 to I think 49. Okay. What does the MCQ stands for? Do you know what is MCQ stands for? Yeah, not very common here. It's multiple choice questions. It's a short form for multiple choice question. Yep. This one will spend about 30 minutes, see how it goes. Okay, then afterwards we will be doing the test. Then second part, this is we'll spend about 30 to 40 minutes. Then we'll have a test on chapter 2. Okay, so that is going to be about 40 minutes. And if the time permits, then I'll continue with the. This is not a test, okay? This is not a test. It's just a revision for us to do. Okay, so all right, let's look at the questions. Let me open the questions. here. Yeah. But before the test, I'm just doing a quick revisions with you using this worksheet. Let me. Yeah. Of course. What do you mean chapter 1? Isn't it chapter 2 on? Of course, I mean, you need to have some basic understanding about this. Yeah, but in the text itself. Okay, but anyway, yeah. Yeah, you can use a data book. Okay, let me open the file first. Let me see. Okay, question 25. We are starting from, covalent substance is from question 25. Bonding of molecule substance, the best explained. So when they say molecule substance, is referring to, whenever they say molecule, okay, whenever you see this word molecule, we are referring to covalent compound. Okay, so this is something that you need to recognize. So in question 25, what should be the answer? The bonding in molecular substance is best explained as the attraction between. Covalent bond is formed between what and what? Is it because of the ion or sea of electrons? No, right? Sea of electrons is ions and sea of electrons are in metallic bond. Okay. So what's the answer for question 25? It's between the two nuclei and a pair of electrons. So it should be A. Okay, so answer for this is A. So covalent bond is always remember, we have when you write down something like Cl and Cl, you have a dot and cross. This one is representing the nucleus. This is representing the nucleus. So it's the attraction between the two nuclei and then a pair of electrons, right? So 25, 26. Yes. Okay. Not really. I think no more here. And can some of you share the data book there? Yeah, it's not here. Mm. Okay, so what is the answer for 26? B. I think it should be A, I think. Let me, why is it B? So you have electronic configurations, you have a 3p3 and then 2p5. So 3p3 and 2p5, how they are going to shape? Phosphorus is require how many electrons? For you to get, so you need 3, right? And then fluorine is 1. Because if you look at P, if you look at this one, P is because it's a 2s. If you look at 2s2 and 3s2, 3s2 and 3p3, that gives you 5. So that means you need to have a 3. For fluorine, fluorine has a 2s2 and 2p, 2s2 and 2p5, right? So you already have 7. So that means you need to have a 1. So it's like 3:1. So it's going to be a PF3, which is T. All right. So this is how you find the molecular formula based on the how many electrons that you need here. So they're going to form something like P with the dot cross. If F, right? Okay, how about 27? 27 is D. Which one of the following element does not form double bond? Does not form double bond. Okay. So how do you know that it cannot form double bond? Yeah, it only needs, fluorine only needs 1 bond, right? So it will not require double bond. So it's D. What about 28? 28 is C. True. Any idea? So what are they looking for? Yeah, how many? Yeah, they are looking covalent bonds formed by the nitrogen atom, which has the electronic configuration of this. Usually, the number of covalent bond, because how many more do they need? They need 3 bond, right? So it's going to be C. Is it C? Yeah. How about 29? 29 is B. Best description of covalent bonding is that it results from sharing of electrons, right? By 2 atoms, which is B. Timothy, are you okay? 30. Yeah, atoms of non-metal. Okay, 31. So that is the comparing between giant molecular structure and simple molecular structure. Okay, so in this case, diamond has a very high melting point and boiling point, while CH4, which is also a compound of carbon. But CH4 has a very low boiling point and melting point because they exist as a small molecule. Okay, only weak bonding between them. So 31 is C. 32. So a shape of a molecule, how is it, what is being actually determined? What is the one that will determine the shape of the bond? Yeah, it's VSEPR, which is a valence electron, VSPR, valence electrons repulsion. So when you are talking about repulsion, you're going to look at the number of bonds is also important, right? So the number of bond pair and then non-bonding pair of electrons determine the shape of the molecule. Okay, so generally the shape is determined by two things. Is a number of bonding pairs as well as the number of what we call it lone pair, which is non-bonding pair. For example, like if you look at like water will form a V shape like this. They will repel each other. That means this bond, this particular bond and this particular bond will also repel each other. But due to the presence of these lone pairs, then their repulsion becomes lesser. So lone pair repulsion and bonding pair repulsion, which one is strong? Lone pair is stronger. Okay, so lone pair is a stronger repulsion. So is it going to be a stronger repulsion? So in this case, for 32, it's going to be C, right? 33. Molecular formula of the four substances are given below. For which one will the structure contain only single bonds? Okay, now we need to recognize we have a CPHO and N, right? C require how many bonds? 4. P require 3 because it's group 15. You need to have 3 more, right? So you look at which group they are at. So if you look at like for this case, C is in group 14, group 15 is P, and nitrogen is in also group 15. So they will require 3 bonds. They will also require 3 bonds. Carbon will require 4 bonds. Oxygen require 2 bonds because it's group 16. And hydrogen require just 1 bond. But for them to be only form single bond, okay, let us say C, right? So if we try to form C, for C is a CH2O. So in this case, C can have 2 bonds with H, but you only have a O. O will also require 2 bonds. So to fill up this, you will have a double bond. So that means it cannot be C. Actually, it's A. Because if you consider A got a CH3, PH2. It's actually is a false CH3, PH2. C will have a 3 bonds here with H. And B will have a 2 bonds with H. But you still have a bond between P and H, P and C. This is what they can form. Right? Because phosphorus requires 3 bonds. Carbon require 4 bonds. Hydrogen require 1 bond. Okay, so that's why for 33 it must be. Got it? No. Which part you don't get it? Huh? Not very sure. Okay, as I mentioned, the elements, the number of bonds that they require to form is 18 minus their group number, right? Remember, this is a group 18 is the one that they want to form. So carbon is in group 14, that means they require to form 4 bonds, right? 4 single bonds. That's what they need. So based on the molecular formula, you need to figure out, okay, H can only form 1 bond. That means H are like something which are peripheral come and attach to them. So you have a C and P, then C and P are in the middle. Then we try to attach, because P will have H2, so I've already attached this 2. So these 2 are done, these 3 are done. So after you have done this, when you do not have this, then C require 4 bond, P require 3 bond. So the final one that you have to form must be between these 2. That's how you consider. Okay, so that's generally by drawing, that's how you can figure out. Okay. So that is for 33. For 34, let me see. Of the molecule of this, the two with the same shape. No, carbon dioxide doesn't have a lone pair. So carbon dioxide is a linear structure. Water is V-shaped. Water has lone pair. Huh? Okay, first of all, carbon dioxide, you need to recall carbon dioxide is generally carbon dioxide, oxygen require 2 bonds. C require 4 bonds. So you will have all of them is filled up. There is no lone pair, right? If there is no lone pair, then they will have a maximum repulsion is going to be 180, right? So that will form like a straight line. But when you have an oxygen have a 2 and hydrogen is this, but you have a in the center is normally what you look at is remember I mentioned that at the center atoms, how many lone pairs that you have the center atoms. So this is in the center atom, if you have a lone pair, because oxygen is already used up. Okay, for this case, yeah, of course, oxygen has a 2 bond, you have a lone pair, but those lone pairs are at the side, so they do not have an effect on the shape of it. You have to look at the center atom. Center atom, for carbon is already used up all of them. There is no lone pair. So there is no effect on the shape of it. Okay, so that's why it's a linear. And yeah. D, why is it D? BF3 and NH3. NH3 is a trigonal pyramid, but BF3 is yeah, it is B. D doesn't, boron is in group 3. Yeah, there is no lone pair. It's a planar structure. Okay. Yeah, it's B because remember oxygen and sulfurs are in the same group. So they will behave similarly. So H2S will also be something like this. V shape. Okay, so it's B. Uh, 35. D or B? D. Pyramid, triangle, pyramid. I thought you mentioned about H2S just now. It's a V shape, right? Pyramid must have three things on the bottom, right? It's a trigonal pyramid. It's something like this, right? Yeah, it's B. Trigonal pyramid is B, which is your NH3. Okay, so it's an NH3. Hello, Howard. Okay. So it's like this. Please try to copy down if you are not very sure. Okay, next 36. What is 36? Of the four molecule, C2H2, HCl, BCl3, and 2, the one with a different shape to the other three are. Okay. Sorry. Yeah, it's C. Okay, C2H2 is simply it's a triple bond like this, and then H here, so it's a linear structure. Because they will form because only C can form four bonds. Okay, that is 36. HCl also the same thing, it's a linear structure. And N2 is also linear structure because it's a triple bond. The only thing which is different is C, which is a BCl3. There is no lone pair.
Yeah, but this
This is polar. No, we are not looking at polar or non-polar.
it's like when it's cross.
Yeah, it's not symmetric. This is not symmetric.
Oh, yes.
They are non-polar, yeah. So C is the one, which is like PCl3. You have a lone pair, Cl, Cl, C. So this is your 37. Which of the covalent bonds shown below is the most polar? Okay. C and H, N and H, O and H, F and H. Which one is the most electronegative element?
Oh, right.
Yeah, fluorine. So which is D, yeah. Fluorine is actually more electronegative than oxygen. So okay, remember we have three hydrogen bonding, right? Hydrogen bonds can form between F and H, O and H, and N and H. Remember, this is what we mentioned. Out of these three, this is the strongest hydrogen bonding. Okay, and then this is going to be the weakest. So in this case, they are looking which one is the most polar. In this case, it should be D. Remember, hydrogen bonding is also a polar molecule, right? It's because of the electron pair are being like attracted. So it's generally F and H. The more electrons will be here. So this will be delta minus, this is delta minus. So the position of this pair of electron, where does it exist? So if you have a higher, more electronegative element will be pulled more towards them. So if you're able to pull more towards them, then it's going to be a more polar. Okay. Okay, 38. Any idea? 38. Of the molecule, the polar molecule is, there is only one polar molecule. Yeah, it's D. The rest are not because they are balanced. As I mentioned, in terms of the shape, CO2 is like this. It is balanced. Okay, and then CH4 is also something like this, which is balanced. Even though individual bonds are polar, they are sort of like in balance, so they cancel each other. CF4 also the same thing. CF4. The H4 is also like this. So the only thing D, which is a pH 3 just now, which is a polar. So pH 3 is something like this. This is going to be a delta minus. B is answer. Okay, 39. 39 is D. Yep. It's non-polar. What is the main reason? The carbon dioxide molecule is linear. Actually, they should say linear and balanced. Not only linear, it must be balanced as well. So, but in this case, other than the other answers do not give the reason, the main reason. So you have to choose D. How about 40? Least polar. Okay, all the shapes are the same. CH3F, Cl, Br, and I. Which one is the least electronegative? Least polar is D, right? All right, is D. Do you know why is it D? It's the least electronegativity. I has the least electronegativity. Okay, the next one is the opposite of it. Which one of the molecule below is expected to have the lowest boiling point? Lowest boiling point means is also a least polar, is it? Is it? Lowest. Yeah. Weakest intermolecular force. They are also polar. And they are polarity decreases. Is it just D? This one is a little bit interesting. How about yeah, this is least polar. Is it just D? What do you think? I also believe so. It has the lowest boiling point. But we must also think about the dispersion force. But dispersion force should not have much of it. Yeah, it should be D. Okay, how about 42? 42 is? 41 is D. 42 is C, yeah. 42. Joined together, covalent bonding might be expected to sometimes have low melting point and boiling point. Yeah, 41 is D, 42 is C. Okay, 43. Which one of the following statement best describes molecular substance? Molecular substance. Anyone has an answer for this? 43? Which one of the following best describes? That means not necessarily if it is, it must be consistently described. Timothy, what do you think? D. I think the question is a little bit weak. I think I should say that which one of the following statement best describe simple molecular substance? Because molecular substance, okay, if I'm going to say molecular substance, just recognize that it is a simple molecular structure. So which is about those small molecules. Okay, so which means that molecules or substance have a low melting point. It should be B, I think. Yeah, because they have a low melting point. They may not be sorry? Yeah, they have a low melting point. When they say molecular, we are not talking about those giant structure. It's like simple structure like carbon dioxide, water, those kind of things. Okay. So in this case, for 43, molecular substance means it's a simple molecule. Okay, they are referring to simple molecule or like small molecule. Ionic bonding is between metal and non-metal. It's next chapter. After the metal, then we are going over to ionic bonding. No. Yeah, but here this particular. Okay, never mind. How about 44? Is order of decreasing solubility in water. Okay, this part I think is a little bit too early for you to be able to understand. So probably, partly yes, but you haven't learned butane 1-O and propane. So I'm not going to asking this type of question because this is actually taken from overall revision paper. So it's like by then you should be able to understand what is meant by hydrogen fluoride, butane 1-O and propane and oxygen. So solubility actually based on the polarity. So the strong highest polarity will be more soluble in water. So actually that answer is B, but it's okay. You may not know all of them yet. Okay, 45. More soluble, yes. The higher the polarity, more soluble in water. That's how about 45? Um, 45 is boiling of methanol, while ethanol is 78. Increase in the strength of the hydrogen bonding, is it? Or dispersion force? Both have a hydrogen bonding, but ethanol has a higher dispersion force because it's a higher number of electrons. Yeah, so it's A, yeah. The reason for higher bonding for ethanol is an increase in the strength of the dispersion force. Yeah, because in terms of the dispersion force, that will be higher. CH3 CH2OH has a higher dispersion force. Because it's larger molecule, right? More number. So it should be A. Okay, 46. Is which one of the compound is expected to have a highest boiling temperature? Yeah, it's B. It's also like a larger molecule. You have a CH3, it's the largest mass. Yeah, it's B. I think it's slightly off in some area because you haven't sort of like learned those things, but you don't really need to know their molecular names for this. Okay, 47. Yeah. In this case, they do not have any this one you have a NH2. NH is a hydrogen bonding. So there are two hydrogen bonding in because it's a NH2. The other one has only one NH. And D doesn't have a hydrogen bonding. Only though N there is no H. So in this case, B has a two hydrogen bonding. That's why it has a highest bonding point. How about 47? C or B? 47, yeah, it should be C, I think. The structural formula of four substances are which one would be expected to have hydrogen bonding between its molecule? Because O is in other things, there is no direct communication, or rather is like connection between those O, N, and F with H. So only C, right? So 47 is C. 48, it's a good conductor of electricity. The conduction of this is so it should be C, right? Because electrons are moving freely. What about 49? Diamond, graphite, carbon nanotubes, buckyball, all forms of carbon. For these material, the number of the carbon atoms, each carbon atoms is bonded to. Okay, this one I think, yeah, you can refer back to that, but generally diamond has a 4 bonds, graphite has a 3 bonds. So you are limited to either B or C. Carbon nanotubes and then buckyball, they also can conduct sort of like, if you go back and take a look based on their shape, they have a 3 bonds. So in this case, answer is B. Okay. Sorry. It's in the giant molecular structure. We've learned in the giant structure. Nanotubes and buckyball, they have 3 bonds each. It's like hexagonal shape like this. So it has a 3 bonds to each other. So it's B. All right. Okay. So I think now I need to ask you to do the test for this chapter. So are you ready to start? Hmm? Yep, we can. We can use the notes. It's fine. I just want you to check your understanding of it. So you may refer to your notes. You can refer to the notes if you want to. Can someone move the place? All right, let me give it. Yep. It's maximum 40 minutes. If all of you finish earlier, then we can stop it earlier. It should be fast, that's not a very difficult paper. Okay?
Is it over?
No. There are structured questions at the back. Okay, can you move? Chapter 2. Yeah, covalent substances. Actually, whatever that you have in your brain, then you just use it. Can we start? Okay. I think you can start because it's like in terms of the time interests, I'll have to start. Yeah. Data booklets. Okay. I will have to ask them to print again because yeah, you can actually share. It's the best, I think. Okay, for Theo, I think you should. I'm not sure whether they have sent you. If you have it, you can also write down, print out, and then do on the paper and send the photo back to the office, or you can bring that one back tomorrow when you come.